3 months ago, a typhoon killed 17 people in the Mariana Islands. It wiped out the entire power grid on the island of Tinian. It left more than 450 families sleeping under FEMA tarps instead of roofs. That storm was called Sinlaku. Right now, a second storm is bearing down on those exact same islands. Not a smaller one, a stronger one. Forecasters expect it to reach Category 5 by Monday morning, and it is arriving before a single one of those roofs has been rebuilt. Its name is Typhoon Bavi. By the end of this, I'll show you the exact mechanism inside this storm that is about to make its winds explode in speed. Why that same mechanism is about to widen the damage across 4 islands at once instead of one, and why thousands of people are facing a second direct hit while they are still living in tents from the first. Welcome back, let's get into it. As of 7 p.m. Chamorro Standard Time on July 3rd, Typhoon Bavi has sustained winds of 105 miles per hour, 169 kilometers per hour, with gusts to 120 miles per hour, 193 kilometers per hour. Its central pressure has dropped to 955 millibars. That is a strong, dangerous storm on its own. It is also, according to the Joint Typhoon Warning Center, nowhere near finished. Bavi is tracking west-northwest, threading the gap between Guam and Saipan, on pace for its closest approach Sunday night into Monday, July 5th into the 6th. Roughly 50,000 people sit directly inside the path of Category 1 or stronger winds, concentrated in Saipan, in Hagatnya, in Dedido. Guam's government put the island at condition of Readiness 3 at 3 p.m. on July 3rd. The Commonwealth of the Northern Mariana Islands declared a state of significant emergency the same day. The Global Disaster Alert and Coordination System issued its highest classification, an overall red alert, for the region. Here's the part that should get your attention. Most people are watching the wind number, the number climbing toward 105, then higher. But the people who study this storm for a living are watching something smaller and stranger happening deep inside it. They are watching what the storm's core is doing. And what that core is about to do explains almost everything else in this story. We'll come back to that, because it changes how you should read every number that follows. Let's start with why this storm is intensifying so fast in the first place, because everything downstream depends on it. A typhoon is a heat engine. It takes warm ocean water, converts that heat into wind, and keeps running as long as the fuel holds out. Right now, the water underneath Bavi is running at 29 to 30 degrees Celsius, 84 to 86 degrees Fahrenheit. Ocean heat content in the storm's path is measured above 100 kilojoules per square centimeter. Translate that into plain terms and it means this. The ocean underneath Bavi isn't a puddle of warm water sitting on top of colder water below. It's warm all the way down. A storm can usually cool itself off by churning up cold water from beneath. Bavi can't do that here. There's nothing cold to reach. Think of it like the difference between a household water heater and an industrial boiler. Your shower runs cold after 10 minutes because the tank empties out. An industrial boiler doesn't run out. It just keeps making steam. That's the ocean under Bavi right now. On top of that fuel supply, the sky overhead is almost perfectly still. Vertical wind shear, the change in wind speed and direction at different altitudes, is sitting at just 10 to 15 knots. Picture a candle flame in a closed room with no draft. The flame burns straight up, tall and undisturbed. That's Bavi right now. No crosswind is coming through to knock its structure sideways or choke off its rise. Forecasters expect that shear to eventually climb to 20 knots within 60 hours, 30 to 35 knots within 5 days. But that increase may come too late to matter for the Marianas. So you have maximum fuel and minimum interference. That combination is what meteorologists call the preconditions for rapid intensification. And it's why, in the space of about 48 hours, Bavi went from an 80-mile-per-hour typhoon to a storm bearing down on 105, with a projected peak of 174 miles per hour, 280 kilometers per hour, by Sunday night. Here's what that number actually does to a coastline. A 130-mile-per-hour wind and a 174-mile-per-hour wind are not the same danger delivered a little harder. Wind force increases with the square of speed. A storm that gains 40 miles per hour doesn't hit twice as hard. It hits closer to 4 times as hard. That's the gap between the roof holds and the roof is gone. Now here's the mechanism driving that number upward, and it's the one thing I need you to hold in your head for the rest of this video. Picture someone spinning on an office chair with their arms stretched out wide. They're spinning at a lazy, manageable speed. Now picture them pulling their arms in tight against their chest. They don't push off the ground again. They don't do anything extra at all. And yet they suddenly whip around far faster than before. That's not a trick. That's physics. It's called the conservation of angular momentum, and it means that when spinning mass moves closer to the center of rotation, the speed of that rotation has to go up to compensate. A typhoon's eyewall does the exact same thing. As Bavi organizes its ring of strongest winds, meteorologists call this the radius of maximum wind, is contracting, pulling in tighter around the eye. And exactly like the person on the office chair, that contraction forces the rotational speed to climb sharply without adding a single new unit of energy from outside. The storm isn't gaining strength from nowhere. It's redistributing the strength it already has into a tighter, faster spin. That's the arms pulling in. That's the mechanism behind the jump from 105 to a projected 174. But storms don't just tighten forever. And this is the part almost nobody outside a meteorology office is watching, the detail that reframes the entire threat to these islands. As an intense typhoon nears its peak, it often builds a second eyewall, a wider ring of thunderstorms forming outside the original one. Picture a fast-growing vine sprouting in a circle around the base of an old tree. As that vine thickens, it steals the sunlight and the rainwater the tree needs. The trunk inside, starved, begins to rot and hollow out, while the vine keeps climbing, keeps widening. Inside a typhoon, the new outer eyewall does exactly that. It intercepts the warm, moist air the original inner eyewall depends on. Starved of fuel, the inner eyewall collapses. The outer ring takes over. This is called an eyewall replacement cycle, and it does something counterintuitive. Picture a flashlight on a tight, blinding spot beam. Now twist the lens to flood mode. The center dims slightly, but the light now covers the entire room. That's what an eyewall replacement cycle does to a typhoon's wind field. The absolute peak number at the center can actually drop a little. And at the exact same time, the radius of destructive wind expands, sometimes dramatically. The storm gets, in a sense, less sharp and more wide. Now put those two mechanisms together, because this is the sentence that explains why Bavi is dangerous to 4 islands simultaneously and not just one. The arms pull in, and the wind speed spikes. Then the arms go wide again, and the danger zone spreads to cover far more ground than the peak number alone would suggest. Saipan, Tinian, Rota, and Guam sit close enough together that an expanding wind field from an eyewall replacement cycle could put damaging winds over all 4 islands at nearly the same time, instead of sparing the ones the eye happens to miss. That's the chain. Warm ocean feeds the storm. Calm upper air lets it organize. The core contracts and the wind number spikes. The eyewall replaces itself and the danger widens. And on the ground, in Saipan and Tinian, that chain arrives as wind hitting structures that are already broken. This is not the first time this exact chain has run its course over these same islands. And that history is the reason officials are not treating Bavi as routine. In April of this year, Super Typhoon Sinlaku struck the Marianas after intensifying 75 miles per hour in a single 24-hour stretch, eventually peaking at 185 miles per hour, 298 kilometers per hour, briefly the strongest storm on Earth in 2026. It killed 17 people, the deadliest storm in the Micronesian region since 2002. More than 13,000 people were displaced. Over 7,000 homes were damaged or destroyed. On Tinian, the entire electrical grid failed completely, and it has not been rebuilt since. On Saipan, more than 450 families are still living in FEMA tents or under tarps where their roofs used to be. Andersen Air Force Base absorbed $40 million in damage, with more than 90 structures still waiting on repairs months later. Sinlaku is not the only precedent. In October of 2018, Super Typhoon Yudu struck Tinian and Saipan with winds of 170 miles per hour, 274 kilometers per hour, nearly identical to Bavi's projected peak. Yudu killed 35 people, displaced up to 17,000, more than a quarter of the northern Marianas population, and knocked down 962 power poles. Some of those grids stayed dark for over 6 months. And in 2023, Typhoon Bavi, moving at a crawl of just 8 to 10 miles per hour, sat over Guam long enough to flood the island's hospital and damage its fuel piers, killing 6 people in the process. That is the pattern hardening into precedent. This is not a fresh island meeting its first storm. This is the same grid, the same tents, the same unrepaired base, facing a typhoon that could match or exceed the worst of what came before it. It's worth being honest about scale here, because this is exactly where online discussion tends to run away from the data. The 174 mile per hour figure is the high end of the model guidance, the number from the Joint Typhoon Warning Center's most aggressive projection. Other agencies are lower. The Japan Meteorological Agency's 10-minute sustained wind estimate translates to roughly 180 kilometers per hour, about 110 miles per hour on that measurement standard. The NAVGEM model projects a peak closer to 138 miles per hour, 222 kilometers per hour. That's a real spread, and it matters. Bavi is not a locked-in, guaranteed apocalypse number. But here's the reaffirmation, and it's the point of everything you just heard about eyewall replacement. The real danger was never chained to hitting the exact top of that range. Even if Bavi peaks nearer the middle of the guidance instead of the extreme edge, the same widening mechanism still applies. A storm that spreads its destructive winds across all 4 islands doesn't need the highest number on the chart to be catastrophic for a population already living under tarps. It only needs to arrive. There's a specific, dangerous myth circulating right now in local Guam social media threads, and it deserves a direct answer, because believing it could cost someone their evacuation window. The claim going around is some version of Guam will be spared, like always. The idea that the island has some kind of geographic luck, a protective bubble, storms that mysteriously curve away at the last moment. Here's why that isn't how any of this works. Bavi is a heat engine spanning hundreds of miles of ocean, and its track right now is being steered by a massive subtropical ridge of high pressure sitting to the northwest, a synoptic-scale force operating over thousands of miles. Guam is about 210 square miles of land. It has no mass, no elevation, and no thermal footprint capable of nudging a system that size off its course. When a storm has appeared to spare Guam in the past, that was a shift in the ridges and troughs steering it from far away, not the island deflecting anything. Relying on that myth to skip preparation ignores the actual physics driving a storm with 105 mile per hour winds toward the coast right now. There is a separate, legitimate scientific debate worth knowing about too, because not every disagreement here is a myth. The consensus track, built from models like the GFS, the HWRF, and the HAFSA, has Bavi passing between Guam and Saipan. But two credible outlier models, NAVGEM and the ECMWFAFS, are pointing the storm's eyewall directly over Guam instead. That's not a fringe theory. That's professional meteorologists genuinely disagreeing about where a real storm goes, and it's exactly the kind of uncertainty worth watching, not dismissing. Here's exactly what agencies are watching over the next 48 hours, and every one of these is something you could check yourself. Whether the National Weather Service upgrades Guam's typhoon watch to a typhoon warning, meaning impacts inside 24 hours instead of 48. Whether Guam's condition of readiness drops from 3 to 2 or 1, which would trigger a full lockdown of government and base operations. Whether the U.S. Coast Guard escalates its port status from Condition X-ray to Condition Yankee, something they say could happen as early as 8 a.m. on Saturday, July 4th, closing the ports to inbound traffic entirely. Whether Bavi's forward speed, currently slowing from 16 to 13 kilometers per hour, drops further, prolonging exposure over the islands the way it did during Malwar. And whether that eyewall replacement cycle actually materializes on satellite before landfall, which would confirm the wind field is widening exactly as the models suggest. Behind every one of those numbers are people who have already lived through this once this year. Caitlin de los Reyes is a lifelong resident of southern Saipan. When Sinlaku hit in April, she was the primary caregiver for her 94-year-old bedridden mother. She'd survived Yudu back in 2018, so she expected Sinlaku to be what locals call a banana typhoon, nothing special. At the beginning it was okay, she said afterward, but later on it wasn't. The wind tore the boards off a window. Rain poured through her ceiling and soaked the mattress. She, her partner, her daughter, her mother, and their 2 dogs crowded into the one room in the house with a concrete roof and concrete walls, and they stayed there for days while the storm sat almost motionless on top of them. She could hear sections of her roof tumbling away outside. She prayed it would end. When it finally did, her family became one of more than 450 in Saipan now living under a tarp in a FEMA tent, and her first job afterward was clearing her own driveway, so an ambulance could reach her mother if it needed to. On the island of Tinian, Andrew Hofschneider lost his own home in that same storm. A longtime American Red Cross volunteer, he spent the weeks afterward inspecting his neighbors' wrecked houses to connect them with help, all while he had nowhere of his own to go home to. On July 2nd, as Bavi's outer rain bands began sweeping across Tinian, he was photographed at Tinian International Airport in a driving rainstorm, loading 1,400 pounds of emergency relief supplies onto a truck to get his community ready for the next one. He is still displaced. He is still showing up. Zoom out, and Bavi stops looking like one unlucky storm and starts looking like a pattern. Globally, the probability of a tropical cyclone undergoing rapid intensification has climbed from roughly 5% in the early 1980s to 10 to 15% by the late 2010s. Intensification events happening within 400 kilometers, about 250 miles, of a coastline have tripled since 1980. The 2026 Pacific typhoon season alone had already produced 12 systems by mid-June, the fastest start since 1976, with every single month of the year generating a named storm, something that hadn't happened since 2015. The ocean water fueling all of it is running about 0.6 degrees Celsius, 1.1 degrees Fahrenheit, above average. And climate models suggest that specific level of ocean warmth was made 70 to 100 times more likely by climate change. This past June, the Federated States of Micronesia joined 140 nations at the United Nations affirming that governments hold a legal obligation to limit greenhouse gas emissions and address the damage they've already caused. The United States, which holds sovereignty over both Guam and the Marianas, was one of only 8 countries that voted no. Rebuild Math tells the same story from a different angle. A year after Typhoon Bavi hit Guam in 2023, the U.S. Air Force estimated it needs nearly $9.7 billion to repair and harden its facilities there, more than double the $4.389 billion combined that it spent rebuilding Tyndall and Offutt Air Force bases after their own stateside disasters. The infrastructure keeps getting hit before it's ever rebuilt to survive the next one. The arms are pulling in right now over open water, hundreds of miles from land. In the next 2 to 3 days, they'll go wide again, and when they do, Saipan, Tinian, Rota, and Guam may all feel it within hours of each other, whether or not the eye passes directly overhead. Nobody knows yet exactly where that eye tracks, or exactly how high the wind number climbs before shear finally starts to cut it down. What we do know is what to watch, and now, so do you, the readiness level, the port condition, the watch-to-warning upgrade, the satellite imagery of that second eyewall forming. 50,000 people are inside this storm's path this weekend, many of them still living under the roof Sinlaku left them with 3 months ago. We'll be tracking Bavi's track and intensity through landfall, and we'll bring you the actual numbers the moment they come in.